low-cost image processing tools which are available to city transportation, city or state transportation infrastructure, so that life for drivers and cities become easier.
Hello, can you hear me? There we go. My name is Nicholas Johnson. I'm the CTO of Sunwaves, a company using cloud computing to basically manage traffic. We actually tap into cities' infrastructure and take control of traffic lights in a way that is intelligent. We collect data from multiple sources and then use that data to basically optimize traffic flow. We're currently in our pilot with the city of San Jose, the next 2 to 3 months to actually roll this out onto a small section of city streets. We're aimed very specifically right now at buses, so we do a service called public transit priority, where buses get priority to increase the service for buses, travel time and operation cost, and we also do emergency vehicles. Our overall goal is to kind of alleviate traffic over time by figuring out how to optimize the actual lights that control traffic. We actually have no hardware, so we're a software-only company, which is a little different than a lot of people in this space. And look forward to telling you a little bit more about it.
Well, good afternoon. My name is François Dion. I'm a senior researcher at UC Berkeley in the PAT program. We do focus a lot on how to leverage new data source and new technology to improve transportation network. And that involves a lot of collaborations with public transportation agencies, consulting firm, and focusing a lot on deployment projects.
Hello, good afternoon. My name is Ming Li. I was the president of our association. Today you are the event. We had last year event at the same place, okay? But I'm also a president of a new startup company called Integrated Green Energy Technology. This integrated green energy technology is concentrated, focus on the outdoor, utilize the battery, supply the power. Okay, so one of the system we're working on is the outdoor LED with camera integration for traffic monitoring. So I think this panel talking about smart transportation, that will be one of the subjects we will talk about.
Okay, that's great. So we have a very brief introduction to each one. So now I'll just ask a few questions, then we'll go from the beginning as well. Okay. So we know that the data is very important now. Everyone tries to utilize the data to understand the traffic conditions and develop the strategies to improve the transportation progress. So based on your technologies, and I saw that you have a very nice car outside as well, right? So could you just elaborate about your like a facial recognitions and how you accumulated data and to supply to improve the transportation safety?
Right, so like you mentioned, we believe that any good AI technology relies heavily on good quality of data more than the quantity of it. For us, we started about 4 years ago, and there was really no publicly available data sets that we can just leverage and train the algorithms on. So we had to start from the very beginning in collecting our own proprietary data, and that is real-world data. So there was no simulation. We regularly hire subjects for about 1-hour sessions at our lab in San Jose, and we instruct them to both simulate certain emotions, look at different markers within the vehicle, wear different props, sunglasses or hats, etc. And at the same time, we also had to give them the task to go on a real-world drive-in scenario. And the combination of both gave us really kind of controlled data to annotate, train the algorithm on, but also it gives us a basis against which we can compare the real-world data that we collect. in drive-in scenarios. It's a daunting task. It takes us a lot of time, a lot of effort, and a lot of individuals from 5 different races, 2 genders, and from 10 different groups, and there are different lighting conditions with different camera positions, different camera types, et cetera, and all of that is for the purpose of achieving a high level of accuracy within a specific environment. And of course, once that environment changes, we have to do it all over again. And which is the reason why we focus on production with OEMs for the next generation of vehicles. You mentioned the vehicle outside, so we had to collect a lot of data from that vehicle over the last couple of years, and whatever algorithm we run or we deploy in that vehicle is very customized to that environment. I have to add, initially we started with emotion AI, and then we expanded into the suite of face analytics. Today we do about 30 analytics from the face, including age and gender and eye tracking, eye openness, head pose, head nod, 7 universal emotions, microsleep, yawning, pretty much anything and everything somebody can derive from the face. So we call it a true face reading AI. And then we launched an initiative last year for upper body tracking using the same standard 2D camera. So the same camera is looking at the face, it's also looking at the upper body region. And with that, we have a real-time body tracking algorithm from which we can derive actions and activity recognition from within the vehicle. So yes, it is a lot of data.
Great. Okay. With that data for the human being, right? Basically, now we focus on the car. Okay. So, Hassan, would you elaborate your video genetics technologies that which has video to understand the traffic situations?
Okay, yes. So, yeah, so we are almost always operating outside the car. So imagine a road, a 2-way road, each can be multiple lanes. And imagine one camera pointing at each road. You know, on both sides, so typically you'll have 4 at an intersection. And then imagine license plate reading cameras. So if the cameras are networked, and if a low-cost computer is networked, the low-cost computer can be anywhere. It can be, you know, in proximity of the junction, or it can be in the cloud, or anywhere in between. So if you think of that system is basically through our company's software. It is capable of accurately detecting any violations, speed violations, red light violations, you name the violation, parking violation. Also it will tell you who violated it based on the, you know, the license plate reading. And so we are typically, you know, so this is a technology that has been around for some time, but gradually it is being, not gradually, at a very fast clip, it is being embraced by cities. Because, you know, and also the same information at higher level can be used to understand traffic pattern for any given, you know, hour or minute of the day. It could be real time, or you could use it for statistical purposes. So, so it is, at the end of the day, it is not about only detecting violations. It is also about making the city traffic engineering folks, you know, smarter in the sense that we give them more tools to analyze, you know, what could be done to improve. This morning, very briefly, maybe in a couple of sentences, we heard Mayor of Sunnyvale, you know, who started with one pilot program at one intersection, and then, you know, through Google's encouragement and maybe financial help, they were able to network intersections. So if imagine if all networks, all the intersections on your, you know, are networked, it can communicate tremendous amount of traffic information. And monitor, control the information to make our lives easier.
Okay, that's great. I just want to make sure. So you're saying that Sunnyvale will implement one intersection?
No, if I heard him right,
Okay.
they started with one intersection, and that by itself eased traffic situation going in and out of Google. And so Google was so impressed with the system.
Yeah.
They are now helping the city financially so that they can make things easier for their own employees as well as city.
Okay, that's great. I just want to add one more thing. And last week in the San Francisco Metropolitan Transporting Agency in the downtown San Francisco, we had a meeting where the Google made a presentation. They established a program. It's called the CCP, Connected Citizen Program. It's global programs, and then they will work with each cities and public agencies to communicate, to share the data both directions. They provided their Google map data to the cities, and also they will in return they will try to receive the data from the cities as well. So it's a both way communications. Okay. And then the next, Nicholas, you're going to talk about your program.
Well, so kind of to touch on this point, I think the city was Mountain View. And yes, Mountain View did implement a vision-based system that looks at cars traveling through an intersection and entering and leaving. What we did when we started this, we looked at what vehicle communication means, what the future of vehicles look at, and used that information to kind of build up a solution that actually is deployable quickly to keep up with technology and also cost effective. One of the things with cameras or installing at intersections is most cities themselves suffer from two things: one, lack of budget, and two, lack of resources, normally humans. So anytime you ask them to install something, it becomes an ordeal and can take up to 6 to 10 months. So to get around that, we found a way to kind of go off what he's saying is there's a lot of great data out there already for traffic. We basically give data to Apple or Google every day we drive somewhere using their mapping service. Plus, we collect data at the intersections that is usually stuck at the intersections. You mentioned networking traffic lights. We found when we did our research that 2/3 of the US has already networked their traffic lights. They don't, what that actually means though isn't networked to the internet. It's a private network that is local to the city. And the cities themselves are not willing to open up those networks for really good reasons. There's no security on them. So in our process of developing that, we have to overcome those technical hurdles to make that a solution that actually can grow quickly, that doesn't cost the city any money. We actually found a way to leverage their current infrastructure, so nothing has to be installed, and we use other types of data that's in real time to make real-time decisions for those traffic intersections. So like you were mentioning, you could monitor historical and future data. That idea is really interesting because how we look at data right now is a problem, but the amount of data you're getting when you add any type of vision, as you both know, is very computationally intense, which usually means costly. Again, something you want to try to avoid. So we've really thought about how to drop the system down into something that actually solves the problem in the most efficient way possible. And what that actually means is time and cost. By using telemetry data, we don't have to do any vision computation. We know where vehicles are, and it allows us to build really cool applications such as bus priority and EV preemption. And same thing with vehicles. So once you have more data coming in from things like ride sharing, Waze and Lyft are collecting that same information all the time, you can start to build these really cool models and use deep learning to optimize traffic flow. And the big thing, the hurdle that all of us will actually have to overcome is working with cities. Well, not you. You get the benefit of working with OEMs. But the thing that is really interesting in the last year, we've discovered that cities are actually reaching out to try to solve a lot of their own problems in the tech industry and are creating pathways to allow companies, especially startups and corporations, to interact in a more playful manner, I'll use that word, in a way that actually is coherent to both of them. They both benefit, and that's really awesome to see. I think when we first started, the discussion was very different with cities and federal and state government.
Nicola, just one question. In your case, you mentioned about your system that they can work with the city, right, to improve traffic signals. And then in the Bay Area, there's a programs, it's called the PASS programs, and monitored, managed by the Metropolitan Transportation Commission, which it basically manages like 8 millions of populations in the entire Bay Area of 9 counties. And then they have a particular program just for that. And then in order to get into this program, that means you have to participate in public bidding. It's not just talk to the city and city give the funding, but basically you have to bid for that project. So that's just one step, kind of difficulty usually for a lot of startup. Okay. So next, we'd like to invite Francois to talk about the UC Berkeley initiative, which is easy to do, right?
No, it's not easy to do.
Okay.
I keep hearing the problems that my 2 colleagues here, or 3 colleagues mentioned, and I've experienced them at one level or another. Our chief main program at this time has been the design and the implementation of decision support systems in the cities of Pasadena, Arcadia, Monrovia, Duarte, down in LA. With the idea is that we want to provide a way for transportation managers and also emergency providers to better manage the transportation network when incident occurs. I would love to extend it to regular congestion, but right now they just want to deal with incident. And the chief problem in that is really how can we leverage existing data in one part that does exist, and as was mentioned before, it either is being generated at an intersection and it just doesn't go anywhere else, or it's collected by a fleet company. They're tracking trucks, or even Google, the Apple's a company that getting pro vehicle data. Ideally, I'd love to get my hands on all that data, because we need to understand where people are going. Not necessarily, in part where they're coming from, but I'm really more interested, based on where they are now, where are they going? So when something happens, I can do something that's more efficient. Most of the time these days, we have to rely on one person sitting at a desk, and he's using his judgment to say, oh, yeah, this is happening, this is what we should do. We have no way of knowing that this is always the best solution. It is in some cases, in some other cases is not. So what we're trying to do is, again, collect all the data. Problem filtering this data, because a lot of the transportation data is noisy, it's dirty. There's some things that happens with it that doesn't make sense if we don't know the context, even though the data might be valid. And then once we filter that, is to use it to make a decision. So trying to make a prediction in the future, and prediction is the hardest thing. The best solution to optimizing network is to predict not a year or that far in the future, really in the next hour, the next hour and a half, next 2 hours. Not easily to do when I don't know where people are going. That means relying on historical data, relying on the real-time data that we collect, and somewhat have the processing power to aggregate this and make a prediction, either through simple data analytics or through a simulation model. And the last part of the program is to design a solution that is agnostic to the various technology that exist. Because if not, it will be a solution that's typical for one city or one region, but cannot be exported, that cannot be implemented elsewhere. So that means understanding what are the standards behind the data. And often these standards are already outdated themselves. And so then figuring out what is the best way of collecting the data, so that anyone who may provide the data understand, okay, you have a new technology, you're generating data. In order for us to use it, some specificity that needs to go with it. And that makes the job a lot easier, but it's still within a very complex problem.
You work at Path, correct?
Yes.
We should meet up.
Definitely.
We were actually partnered with Path.
Yeah.
We're working with Path right now regular since when Kuhn and Ben, but I'd love to talk to you more. I think you'd like what we're working on,
Yeah.
and we have not actually had the opportunity to meet. Sorry, everybody.
No, but I talked to your colleague earlier. So.
That's why this, the network is important. You have a question? We don't have much. Okay, just ask one question. Yes.
You have apps like Waze.
Yes.
Look and predict where your bottlenecks are and then suggest
Mhm.
alternate routes. They don't have any access to city data, but they're still able to provide that through smartphone
Yes, it is.
locations. So can any of you use similar approach to come up with this?
We are doing that. That is 100% what we're doing. So to your point, yes, they collect amazing data, but they have no control over how the infrastructure behaves, and the city has no access to their data, which is great to hear that Google is going to try to help solve that. We've been talking with a number of entities, both public and private, about how to break down that barrier of how they share data. I don't know how many people are familiar with APIs, but APIs are a great way to share data, and there aren't great APIs from the government giving data out. And like he was talking about the standards, there's standards written from 1996 that are amazing if you actually can leverage them, but nobody has leveraged them, and we're not sure why, actually. But we are doing that. We are figuring out ways to cross that chasm between private data and public infrastructure. And once you can no longer just reroute a car, but actually control the infrastructure, you can do amazing things.
And I will add to that if I can. Waze is good in many ways because it's a way of communicating with drivers and telling them where to go. The current issue with Waze is that it doesn't have predictive capability when you're facing like an incident or an unusual day. So it tends to send people in waves that in places that city transportation managers says, okay, we should not be sending traffic. In trying to resolve this problem, we have engaged with Waze and trying to discuss with them and say, if we're implementing a detour, then we're going to change, for instance, the traffic signals along this detour. Why not communicating to them what is going to be done so that they can steer traffic in the places that we want to go?
I think
sure.
one of the mayors this morning made
Yeah.
a comment that her city is working with Waze
Mhm.
and letting Waze know when they have road closures or repairs to update the route.
I just want to add that last week, because this morning there's mayor from Fremont, right?
Yes.
Lily May did mention about the city's work with Waze to resolve a lot of issues that he mentioned.
Mhm.
And the last week, the director of the public works of the city of Fremont made about 30 minutes presentation about how they work with Waze. From at the beginning, they accused Waze that deviate a lot of traffic from highway into the local arterial, to now where they work together, they send both information to the Waze, and Waze incorporate their solutions into their algorithm. So they're working much better. And I'm glad this morning that the mayor also very support these initiatives as well. But we will say, okay, next, I think only 3 minutes for me. 3 minutes. And now we have heard that we have a lot of technology.
That's what you get for putting this-
We have a
this
company,
panel
large and
together.
small, working in this area. So we heard that Google, we have a small company startup as well in this case. So Min is going to talk about a kind of new initiative about we call the Smart City Consortium in the Min.
Okay, yeah. I think we heard all the talking about each company's solutions and the data and also the